In the 2012 release, there's a number of improvements also that we've added into Batch to facilitate scene linear workflows that are becoming more and more ubiquitous. And the first thing is in the Lut Editor, there's been a lot of requests on the forums about how to actually convert scene linear footage into something that would be more video-like, and how would you make it look the same as in other applications such as Nuke. Well, the first thing that I want to point out is that if you go to the Lut to the Lut node, or any instance of the Lut builder, which may be either in the clip inside of Batch, the desktop module, or the node, you will notice here that you'll have a preset pop-up. Now, if, for example, I wanted to convert this scene linear image into something that would be more video-like, I can actually select amongst a bunch of presets here, and one of them is scene linear to video for images, which would be appropriate for an image like this. Confirm. So once I do this, I can switch my viewport to video, and it will give me an appropriate rendition, an appropriate tone mapping of the original scene linear image into something that is more video-like. You will notice that the minute that you select that preset, actually it pops up a new tone mapping algorithm that we are introducing in 2012, which is called PhotoMap. You don't really necessarily have to worry about the details of PhotoMap if you don't understand anything about tone mapping. The presets are there for you to assist you in setting up the tone mapping in an appropriate way for most of the situations that you may encounter. Now, one very common situation is if you want to compare results with another application, and mainly typically what Nuke would do, you have a preset here which is scene linear to video via sRGB, which kind of reproduces what Nuke does. And so if I select that, what this will do is essentially just apply an sRGB curve to the image to convert it into something that is more video-like. Note that this is typically not a very good tone mapping strategy, but since it's very common, we actually thought of adding it as a preset just for the sake of visual consistency across multiple applications. If you actually want to do something that is an appropriate tone mapping that gives you a pleasing result, you should select scene linear to video for images, which will actually do an appropriate tone mapping, which by default should give pleasing results on a video monitor. Talking about PhotoMap, so PhotoMap is actually, again, a tone mapping utility that essentially allows you to control all of the different characteristics of, let's say, a virtual photographic system, which is basically what tone mapping is about. It actually separates the visual, the display conditions labeled as encoding from the actual characteristics of the photographic system that you're trying to simulate. So one important thing to understand about PhotoMap is when its settings are left at 0, it's actually performing already a a tone mapping. And so let me switch to Gamma 1.0 for you to understand what is going on. So with Gamma set to 1.0, what you will see is that those different parameters of PhotoMap actually allow you to control the shape of an S-curve that kind of that simulates a virtual photographic system. And based on, and essentially you'll be able to control every single characteristic of the various portions of the curve. The very high portion of the curve, the slope of the intermediate high portion, the slope of the middle portion, again here the slope of the lower portion of the curve, and the very bottom of the curve. So those are typically really the different portions that you can control with the different settings here. So if I go to highlight detail, you will notice that as I tweak this, I'm actually adjusting the slope of the very top of the S curve. Now, I'm not seeing a perfect S here because essentially, typically, a photographic system assumes a logarithmic scale on both horizontal and vertical axis, which I don't have here, so it's a bit of a deformed S that I have here. But essentially here what I'm moving up here is what is the again the very top portion of the S, which will then have an effect on the highlights. Highlight contrast will actually control the slope of the intermediate portion here in the highlights. So it will actually have an effect on the overall contrast, perceived contrast of the highlights. The contrast parameter is going to actually adjust the slope of this middle curve. So if I actually start changing the contrast, you see how my S is kind of pivoting around around the middle portion of the curve here. Shadow contrast is actually going to affect the slope, and so let me just zoom in here so that you better see what's happening in the bottom portion of the curve. As I adjust the contrast, you see that it's actually adjusting here the slope of this darker for the darker regions, and this will actually have an effect on actually creating like really deeper blacks. Shadow detail, on the other hand, again, I'm going to zoom in so that you see, since I don't have a logarithmic scale, actually allows you to offset the very bottom of the curve. And as I adjust this, it actually allows you to essentially remove like two blacks that would be too dark. You can actually shift it up and down here to control actually the minimum level of black that you would want inside of the tone mapped image. Now again, if you don't want to actually worry about any of this, you should feel very comfortable using the presets. And again, here you have video to scene linear via sRGB, which will provide again a similar. Sorry, I should have used scene linear to video here in this particular context. Okay, which will provide the typical transformation that is applied in third-party packages. But I could go ahead and select a scene linear for video to images. You see, I also have a setting to go from scene linear to logarithmic, from logarithmic to scene linear, which is extremely useful for film scans. So anyway, so these presets are here to simplify things for you, so that you don't actually have to worry about the whole complexity of dealing with a tone mapping and the details of a tone mapping algorithm. Another thing that I'd like to point out is most of the keyers in 2012 actually will allow you to specify the image type that you're inputting. Now, this is going to be very important if you, if for example, you would like to do some keying on a scene linear image. It's important to switch to scene linear. This will internally create an internal transform that brings all the dynamic range of the image into a more suitable color space to actually perform the extraction mechanism. And as a result, you'll have a much more natural control over the keying process, even though you're manipulating high dynamic range images. So something to think about when you're planning on actually doing some keying on high dynamic range images. Remember that now all of the keyers, except for the old discrete keyer, actually will support an image type input. And if you're dealing with 16-bit float high dynamic range images, remember to switch it to scene linear. It will provide an easier keying experience as you're manipulating the different keyers. So if you look at the master keyer, the RGB keyer, pretty much all of them actually now have an image type input that you can select depending on what it is that you're trying to key. Nodes like exposure already had this type of control here, where you would actually select the type of input in order to properly compute exposure. But nodes also like regrain and denoise now have these different parameters, and it's extremely important if you want to use regrain on something that's a high dynamic range image. Please remember to actually switch the input to the appropriate type of image, as this will avoid any kind of negative values or parasite negative values to be generated by regrain. And the custom node, the custom regrain mode also, which now supports the histogram, will allow you to actually generate results that are compatible with scene linear images and will not generate out-of-range values that don't make any sense. Same thing with denoise, which is the new noise reduction algorithm. In the node setup, you also have an image type here that you can switch to scene linear. It's important to do so, again, if you're dealing with high dynamic range images, so keep that in mind. Color correct also introduces one new parameter, which is the pivot. And if you are actually planning on using color correction on a scene linear image, remember that the pivot, if you want to correctly compute contrast, the pivot should actually be set to 18%, which is again the average gray on a scene linear image. So again, you have explicit control over the pivot point that is now available in the color correct, and that's true regardless of which type of image you're inputting. But the one thing to remember is that a pivot should actually be set to 18% on an HDR scene linear image if you want the contrast to be properly rendered with a color correction tool. So something to think about also. One thing that I also like to mention is that Logic Up also now has clamping controls that are actually very useful if you're planning on using certain blend types that simply are not meant to be used with HDR images. A perfect example would be something like Screen. Screen is essentially a blending mode that is designed to expect clamped images. So nothing that would have anything, no negative values, no values above 1. So anyway, so now Logic Up allows you to decide what you want to do, essentially work with no clamping, clamping, or clamp negative. Again, if you do not clamp anything, you should expect certain blend types to provide, and Screen again is a very good example, to provide inaccurate results simply because they're not designed to deal with HDR footage. And that's about it for the new scene linear options in 2012.